Let us now turn our attention to a topic that is absolutely critical in any project that involves data analysis. And that is importing and preparing data. What may look like a boring technical detail at first glance is, in reality, one of the most time-consuming, error-prone, and consequential steps of any analysis or system design process. If the data that feeds your analysis is flawed, your entire model is flawed, no matter how advanced your algorithms or how clever your optimization routines. Garbage in, garbage out still holds true. Now, when we receive data from customers, it rarely arrives in a ready-to-use, clean, standardized format. Instead, the format can vary significantly. Most commonly, you'll get CSV files, tab-delimited text files, or Excel spreadsheets, sometimes exported from ERP systems, sometimes manually compiled. In some cases, you might even receive proprietary database files, depending on the customer's IT landscape and their level of technical expertise. The reality is this: every customer has their own way of managing and structuring data. And even within the same organization, different departments may use different formats, naming conventions, or units of measure. And even within the same department, there often is lots of data to choose from, and different people make different decisions as to which data to pull. This means that before you can run a single line of analysis, you need to perform what is often a tedious but essential task: cleaning and harmonizing the data. Let's look at the top half of the slide. Here you see a raw data dump from a CSV in its human unfriendly form. The columns are separated by tabs, but opened in a text editor for the human eye. This looks messy. It's great for the computer though, provided you know the correct separator and encoding. It is very common to encounter encoding issues, which we'll get into later in more detail. The point is, this is not data you can feed directly into a database or analytical tool. It needs work. When importing data to your Jupyter notebook for class exercises, you may need to specify the separator and perhaps even the encoding of the exercise files. Below that, you see a screenshot from a similar data file, but imported to Microsoft Access, a desktop database management system. It is the same kind of data, but more friendly to the human eye. Microsoft Access, by the way, used to be, and probably still is, a popular tool to analyze data, as you can database work without deep knowledge in SQL. I have used it too, but dropped in favor of Python. And even where Python is not an option, Microsoft Power Query may be a better alternative today. So what exactly do we need to do when we import and prepare data? Let's break it down. The first step is to check and adjust column names. Now, this might sound trivial, but it's not. Different customers may use different terms for the same field. One customer might call it item number, another material code, and another SKU. If your import routine expects one label and the file contains another, the column will not be recognized and your import will fail or produce erroneous results. Standardizing column headers is therefore the first step toward consistent data handling. If you're working in Python or SQL, this typically means mapping customer-specific column names to internal variable names in your code or your schema. Next, you need to pay attention to the character set. This is a major source of trouble when working with international clients. Common character encodings include UTF-8, ANSI, ASCI, and others. If you choose the wrong encoding, special characters like umlauts in German, accents in French, or non-Latin characters in Scandinavian or Slavic languages may be misinterpreted or replaced with question marks or other symbols. This can break your entire import routine. Worse, it can silently corrupt your data by turning valid values into meaningless strings. Always double-check the character encoding and perform test imports before running large-scale conversions. A practical tip here. Open the file in a simple text editor like Notepad, or Visual Studio Code to inspect the encoding. If your file looks fine in Excel but breaks in your script, encoding is usually the culprit. The third adjustment you often have to make concerns measurement units. Again, this seems obvious, but it's one of the most common sources of calculation errors. Let's say your customer provides product dimensions in centimeters, but your tool expects millimeters. Or they give you weights in kilograms, while your system works in grams. Without proper conversion, your storage volume calculations, bin assignments, and even shipping cost estimates will be off. Always verify the units used, and don't assume the column label is correct. If a customer writes length, it could be in millimeters, centimeters, or inches. Always double check against actual values, or, if possible, ask the customer directly. Now let's talk about the role of documentation. Ideally, your customer should provide a data dictionary, a separate document explaining the meaning, format, and units of each field. But in practice, this rarely happens. More often than not, you'll be reverse engineering the structure yourself. Use exploratory analysis techniques to infer what each column contains. Count distinct values. Look for outliers. Use conditional formatting to highlight empty or suspicious cells. This can help you identify where the data is missing, inconsistent, or simply wrong. Speaking of missing data, it's quite common to find empty fields or placeholder values like NA, 0, or 1 in datasets. These may be intentional, for example optional fields, or they may signal errors. Always clarify what they mean before proceeding. Let's now talk briefly about software tools. Most of us use Excel for quick inspections. That's fine for small datasets. But for anything more serious, say millions of rows, you'll need something more powerful. Access, MySQL, Power BI, or Python are good choices for relational data. Python with pandas and additional libraries is excellent for data analysis. And Power Query in Excel is great for repetitive cleaning tasks and quick checks. Data import is not just a technical step, it is also a form of domain analysis. The decisions you make here, what to include, what to discard, how to interpret a field, shape your entire model. And they are often not neutral. For instance, deciding to remove all rows with zero quantity might seem logical. But what if those rows contain placeholder SKUs that should have been in the warehouse but weren't delivered? By deleting them, you erase valuable information. Let me end this part with a practical suggestion. Keep a log of every transformation you apply to the data. Whether you rename a column, filter out rows, or convert a unit, write it down. Better yet, automate the process using scripts. That way, your work is reproducible, auditable, and less error-prone. And if something goes wrong, as it often does, you can trace it back, step by step. Before we move to the next slide, let me stress this one last time. Importing and cleaning data may feel like a back-office task, but it is a foundational activity. The accuracy of everything that follows, from dimensioning to simulation, from layout design to ROI calculation, depends on it. If you skip this step or do it sloppily, you will waste time, money, and credibility later on. Let's now build on what we've just discussed and take a closer look at one particular issue that can cause a lot of headaches when importing data, and that is character encoding. Let's assume we've imported data from a text file into or a database. At first glance, everything looks fine. But upon closer inspection, something is off. Or perhaps a lot of entries that were supposed to be there are not. And you're lucky to be noticing that, because that's a problem that's easy to overlook. What happened here? Most likely the original file was encoded in one format, let's say UTF-8, and we opened or imported it using a different encoding, such as ANSI or ISO 88591. As a result, characters that were perfectly valid in the original file are now rendered incorrectly. This affects not only readability, but also functionality. For instance, your matching algorithms may fail, category filters may break, or names may not appear correctly in reports or printouts. The orange circles on the slide highlight examples of such issues. Product group names, like the ones shown in the table, contain special characters, in this case from the Norwegian alphabet. If your system isn't configured to accept those characters, it may delete the entire row, replace the character with a placeholder, or misinterpret the field entirely. And here's where the problem escalates. The database management system or import tool may not notify you that lines have been dropped due to encoding errors. They silently skip over the problematic records. As a result, your dataset might look fine, but be incomplete. And this is dangerous. You could be analyzing 90% of the data and not even know that 10% never made it through the import process. In logistics and intralogistics engineering, that missing 10% can contain exactly the edge cases that matter. It might be SKUs with odd shapes, rare customers, or exception categories that need special handling, or fast-moving products. By unintentionally excluding them, you skew your entire analysis and potentially make wrong design decisions. What can you do about it? First, always verify the character encoding before importing the data. If you receive a CSV file, try opening it in a plain text editor and check for unusual symbols. For Python, there are libraries that help you identify the right character set. Second, if you suspect encoding issues, don't just rely on visual inspection. Run automated checks. For example, count the number of rows before and after import. If the number changes, something went wrong. Also scan for null values, special characters, and inconsistent field lengths. Let me close this segment with a simple rule of thumb. Encoding problems are silent killers. They don't scream for attention. They don't cause obvious system crashes. But they undermine the integrity of your analysis. And that's arguably worse. So if something in your dataset looks too clean, too perfect, or too uniform, look again. You might be missing something,